Again, this is not due, so you don't have to turn it in or anything. If you want to just watch, pay attention. If you want to copy them down like notes, they're going to be very helpful for your quiz if you do. Okay. So if you look, we have the function w. Okay. So I want to be clear on this. What this really means. Okay. It was explained in the video on Monday, but this whole thing, this is your output. Okay. This particular thing, the A value, is your input. So in essence, when we plug in a number for A, we're really telling everybody what our input. When we solve this equation, this output will equal our output, as you're going to see in a bit, okay? So I want you to understand that this is how the function works. So a lot of students get confused on this notation here. All this notation is, hey, this is what I'm plugging in, this is my input, and when I solve, this is going to be my output. Whatever number I have here will be my output. Okay, so watch. If you look at our table, they give us some inputs. We're going to input it here, and once we solve for this entire function, that's considered our output. So let's do the first one. So what we're going to do is take our first input and plug it in for A. Okay, so we'll do the work right here. Thank you. So we have W. We are inputting into the function W. We are inputting 0. And so anytime I see A, I'm going to plug in 0. So it's going to be 0 to the third minus 0 to the second. Okay? And now we're just going to do this math. So we have 0 to the third power. Again, we're going to evaluate using order of operation. That's actually 0. And then 0 to the second power is also 0. And 0 minus 0 gives me 0. So what we would say is my output, again, here's my output, is equal to 0. What did I plug in? I plugged in, my input was 0. So we're going to put that here. So my output is 0. So as a reminder, this is your input. This is your output. This is your domain. And this is your range. Okay? Another way you can think about it is this is like your X and your Y. Alright, so it's just a different way of showing things, okay? So let's go ahead and let's do another input. So our next input is going to be 1. So we're going to do the same thing. I'm going to erase this. And now we're using our function W. So we want the output when we plug in the number 1. Our input is 1. So let's do that math. We're going to evaluate 1 to the third is 1. 1 to the second is 1. 1 minus 1. And what do we get? We get 0 again. So my input was 1 and my output was 0. Okay? Let's go ahead and I'm not going to do number 2. You can probably figure out how to do it. I'm going to do number 4 because that's going to be helpful later. So let's do number 4 here. So the function I'm using is W. My input is 4, so I have to plug it into A. So it's going to be 4 to the third minus 4 to the second. Okay? So again, make sure you understand that we are not doing 4 times 3 here. That's not what this is. This is saying 4 times 4 times 4. Okay? This one is saying 4 times 4. So if you do this math right, we get 64 minus 16. And our output would be 48. So my output of W is 48, but my input was 4. So I'm going to put 48 here. Okay, and I'll let you fill in the rest if you want. It's up to you. Okay? So again, this is your input values, output values. They have a weird input value here, but I'm going to show you how to do it. Okay? So now we're going to input. What's great about functions is you can input anything. So as you can see here, we're going to input an actual letter or a variable. So instead of 4, let's input H and see what we get. So let's try that. So I'll use this little part here. So we're inputting H. Okay, so let's clean this up as much as possible. H to the third is just H to the third without parentheses. Bring down the minus. Minus H to the second is just H to the second. We really don't know how to do anything there. And then here we cannot combine these terms because they're different variables. So actually, my function, when I put an input of H, is this. This is my output. Okay? I'm just going to put that in there. So I just want to show you this because when we deal with functions, you can plug in anything into a function, as you will see later on. Okay? So that's kind of how you do the table. If you want, you can complete 2 and 3. All right? So let's jump to the B part here. So let's erase this because we're done here. So the B part says we want to know the domain and range of the function. And here's the hint. We're going to base it off the equation. Okay, so we're looking at this, not the table. So what do they mean by that is, can you think of something? So remember, our domain is input. Okay? So we want to base it off here. Is there any input that we cannot plug in? So in other words, is there any number that it says, hey, we can't plug in this number or something bad's going to happen? Okay? So if you look, there is no restriction saying, hey, your A cannot be 0 or your A can't be negative. We can basically plug in any number for A. All right? So that's what this problem is asking you to do. So our domain, and believe it or not, guys, when we have a function, 95% of the time, this is the domain you're going to have. Basically, we can put any input. As you can see, we even put an H, and it was fine. All right? We could put 1,000 plugged in. We could put negative 1,000,000 plugged in. We can plug in 1/2. We can plug in 0.0483. So in essence, we can plug in any input. When that happens, our domain is called all real numbers, which just means you can plug in any number. But in math, we got to state it like this. Okay? We talked about this last time we met. I don't want you to write it like this. I want you to get used to writing it using math notations. Okay? So there's actually 2 ways to write this. One way is using what looks like an ordered pair. Okay? So what we're going to do here is we want to put what is the smallest number I actually could input into my function. Well, we just said we could plug in any number, including the smallest number possible. Okay? And in math, the smallest number possible is negative infinity. So we can plug up everything up to negative infinity. Now the next number that goes here is, what's the biggest number I can plug in? Well, in math, the biggest number we can plug in is, in this case, positive infinity. So the way you would read this is we can plug in any number from negative, any negative number, and we can plug in any positive number, including fractions and decimals and everything in between. Okay? So that's one way of writing this. Another way of writing the domain of all real numbers is using this notation. Well, we kind of do the same thing. What's the smallest number? Well, negative infinity. What's the biggest number? Positive infinity. And what we do is put these inequalities. Okay? And in the middle, we're going to put our input variable. Our input variable in this case is not x, it's actually a. So the way this works, it says our a value, our input value, can be anything bigger than negative infinity. Okay? Because negative infinity is the smallest number, so we can plug in anything bigger than this, which makes sense. We also can plug in anything less than positive infinity. So in essence, what this statement says is we can plug anything from negative to positive infinity. So any number, basically. So this is 3 different ways of writing all real numbers. I want you to get very comfortable with this format here. This is the one we use most often in Im2. Okay? So now we're going to go to the range. Okay? So the range is this guy. No matter what we plug in, can we get any number? Okay? And the answer is yes. We can get any number because we can figure out a way to get negative 100 if we pick in the right input. Okay? So what we're going to do here is we are going to say our range is also all real numbers. So that means we can plug in, we could get an output of any type of number. As you can see, we even got an output that's an equation here. So we would say this and do the exact same thing here. So my outputs can be in this format as well. All right, guys, I don't expect you to be like, oh, I get it. It's easy. I don't expect that. All right, it takes some practice. We're going to get some practice in it, especially if you get to Im2, you do this a lot. Okay, the difference here on this type of notation, instead of using a was our input, we want to use what was our output for this guy. Our output was W parentheses a. So that's what we're going to put here. What was our output? Because we're talking, range is talking about output. Okay. All right, so now let's go to part C. Again, we're going to get practice with this. This takes a little time to understand. But part C, it says WA, our output, is equal to 18. Okay, so we want to know, when is my output equal to 18? So if you look, we on our table we have an output equal to 0, output equal to 0. We don't know these two, but let's try to figure these out. So I'm gonna do these really quick. Okay, so let's do those really quick and I'll show you how C works. So I'm gonna plug in 2 because I want to know its output. So it's 2 to the third minus 2 to the second. And this is going to give me 8 minus 4. So this is 4. Now let's do 3. So my input is 3, and we want to know my output. So it's 3 to the third minus 3 to the second. That's going to give me 27 minus 9, and we get 18. So let's go back to C here. If we see this, it says, what is my A value? What's my input if my output is equal to 18? So let's look at our chart. Here's my output list. My output is equal to 18. What is my A value? And as you can see, your input or A value is 3, and it's that simple. Okay, so if you complete the chart, it'd be really easy to see. All right, part D. It says, now I want you to find my output, okay, if my input, so again, here's the input. We want to find the output. So if my input is 4, so my A value is 4, what is my output? So we would write, it's pretty simple in the table if you did the table. When my input is 4, my output is 48. Okay? And we're done with part D. So functions are all about input, output, input, output, input, output. Okay? All right, let's jump to number 13. So number 13 says we have these functions here. Okay? And what this says is we're going to take one function. We're going to input 4 into function C. Okay, so let's do that. So function C is actually square root of x. So this really is, when I plug in 4 for x, it's really square root of 4. Okay, and I got that because that's what C says. You're plugging in 4 for C, for x on C. Okay? Now it says we're also going to plug in function A, but we're going to plug in 3. So I'm going to use A now and plug in 3. So we're going to have 5 times 3 to the second minus 2. And what we're going to do is simplify, and then add the two numbers we get together. Okay? So let's simplify this one first. The square root of 4 is 2. Remember, square root is what times itself gives me 4. So what number can you multiply to itself that gives you 4? That number is 2. Let's clean this up. 3 to the second is 9. Okay, 5 times 9 is 45. And we bring down the 2. And then 45 minus 2 is 43. Alright, so now we cleaned up the C function, we cleaned up the A function, and now we're just going to add the two results together, and my answer is 45. So the answer to this is 45.